Very good morning. My name is Giuseppe Conti, and I'm going to go through the several pilots that we are foreseeing within the BRISEIDE project. As you will see, all the pilots share the same interest for spatial temporal operators. So all of them have in common a number of requirements in terms of processing of spatial temporal information. But of course, all of them, they apply those operators in different contexts. Different pilots we have are located in the different countries in Europe and involve partners, of course, of the project. Mainly, we have a pilot in Portugal with the support of the Portuguese Geographical Institute. Then we have a pilot in Spain, Navarra, with the support of the local government of Navarra and Casa. Then we have a pilot also in Trento, in the north of Italy, where GraphiTech is involved together with the local province of Trento, who is supporting the project as user. Then we have another two pilots actually in Czech Republic through the partner CCSS. Then we have yet another pilot in Croatia with involvement of Geophoto. And last but not least, we have a partner in Greece, pilot in Greece with the involvement of Epsilon through the local government of Macedonia and a local agency. The first pilot is about earthquake risk and sees Italy as the test bed and with specific validation in the province of Trento. And the idea here is to localize areas which are potentially affected by earthquakes and their co-seismic risks, as they call it. In practice, whenever an earthquake strikes, then you have a number of collateral effects such as landslides and so on. The problem here is accessing a repository of a temporal repository of previous events, seismic events, and being able to extract information out of them and then identify those areas that can be potentially affected by a landslide triggered by an earthquake. So in this context, you need a number of spatial temporal operators to extract those information effectively. The second, it's more specifically related to landslides, and again here the goal with the support of ISPRA, which is the agency that is in charge of safeguarding our environment, is again to assess how this landslide might affect local population and endanger specific districts in a number of areas. Again, the scenario here will be the province of Trento together with the previous one that will also be evaluated in our context. Then the province of Trento will be also the test bed of the other pilot, yet related to hydrogeological disturbances. And here the goal is to create, is to connect the number of sensors, of local sensors that are deployed in the territory to understand how a possible landslide or other hydrogeological effects might affect local population. And here the importance of accessing spatial temporal information is essential, because basically it's all about evolution of geological events over time, and to be able to understand when those events become dangerous for population. And being able to alert population through the models that they have developed is therefore essential. The further pilot is located in Portugal, in two areas of Portugal, basically the metropolitan Lisbon area and the area of surrounding the dam of Castelo de Pole in Portugal. One being a very urbanized area, the other one being a rural area, so with different again requirements. And the idea here is to track how the land use, the different land use evolves over time by extracting features over time, and then try and understand how this has affected the quality of living. So that means basically extracting how specific features of land cover can be related to variation of quality of water, quality of environment, pollution, and so on. So again, spatial temporal analysis are essential to make all those assessments. Then we have yet another pilot in Croatia with involvement of Geophoto, and this is about management of fire risks in the island of Hvar. I hope my pronunciation is correct. The idea being again to be able to track land use variation following prior and after fire, and being able to understand how variation of land cover can be useful to help operators detecting and planning better countermeasures, for instance, to stop fire or to limit the effect of fires. And then being able to predict through the development of fire, information on fire, how a specific fire might evolve can be essential to help operators on site in case the event should strike. So again, spatial temporal operators are essential for these pilots. Similar focus, but in another context, geographical context, let's say, is in this example in Greece, again about forest fire management. The idea here is to encompass the different stages of forest fire management. That goes from planning to when the event strikes, to analysis of results after the fire has struck, to expose that analysis. So the full spectrum of events that occur through the pipeline, the operational pipeline. And the idea here is to reuse results of a previous European project, which is called SHEAR, which has provided very complex modeling technique to predict how fire can evolve based on a number of parameters going from real-time meteorological conditions on to burn and fuel maps of the terrain, wrap them into an interoperable layer as WPS, and make those functionalities available to the operators, again, in interoperable manner. So again, this is one of the examples of how BRISEIDE is building value-added services on top of existing results from previous European projects.